Alright, hey guys, this is the lecture video for section 14.3 if you want to hear or you want to need more little help on this. This is on inscribed angles, our last section for chapter 13, or 14, excuse me, our first chapter for circles. We're talking about inscribed angles. These are different than central angles, what we talked about before. So let's just begin. An inscribed angle is an angle with its vertex on the circle with two sides that are chords. So let's take a look at our little drawing to the left. Okay, our angle ABC here is an inscribed angle. Its vertex is on the outside or on the circle. Okay, it makes an angle just like that. Angle ABC isn't, and the two sides AB and BC are chords. If we remember from our circle vocabulary, chords are just segments with both endpoints on the outside of the circle. Okay, so this is different from when we talked about central angles. Central angles, the vertex of the angle was the center of the circle. Okay, that's different than an inscribed angle, as you can see. Okay, all 3 points we have for these angles are on the circle. So then we can also talk, using our inscribed angle, we can talk about an intercepted arc. This is the arc that lies between the endpoints of an inscribed angle. Okay, so our intercepted arc for this inscribed angle ABC would be arc AC. Okay, so the measure of our inscribed angle, so the measure of angle ABC here, is equal to half HALF, the measure of its intercepted arc. Okay, so if we look here, we can fill in the blanks for under our little example. The measure of angle ABC is going to be 1/2 of the measure of arc AC. So basically all you do is take the measure of the arc, its intercepted arc, and divide by 2. Okay. So previously when we did central angles, the arc measure was equal to the central angle measure. Now for a inscribed angle, the inscribed angle measure is half of the arc measure. Okay, so next topic is called intercepting a diameter. So if we have an inscribed angle and when its two endpoints right here are also the endpoints of a diameter, or if it intercepts a diameter, then this angle, this inscribed angle, is a right angle. Meaning that the measure, in this case, in our example here, the measure of angle BAC is equal to 90 degrees. Okay, this is useful. So anytime you see an inscribed angle, and you have a diameter going through it, okay, like this, okay, it's going to be a 90-degree angle in there, right? Okay, overlapping arcs. So sometimes we have a bunch of angles in here that you have two angles that intercept the same arc. So if two inscribed angles intercept the same arc, then the angles are congruent. Alright, so in this case, you have the measure of angle ABD. So this angle right here, it intercepts arc AD. Alright, there's also another angle that also intercepts arc AD, and that's angle ACD. Okay, these two are the same. Measure of angle ACD. And it makes sense that they'd be the same because they both would have to be half of the arc measure AD. So we can also write it's equal to 1/2 of the measure of arc AD. Okay. So we'll use these three concepts right here to answer our problems for the rest of the lesson. Okay. So we're given, number one, we're given arc WY to be 62 degrees. The inscribed angle WXY is just going to be 1/2 of 62. Okay. So 62 divided by 2, and that's going to be 31 degrees. Okay, easy as that. Alright, in this one, number 2, we're given the measure of the inscribed angle. So to get the arc DGF, which is this arc right here, we just double the inscribed angle. So 113 times 2 is going to be 226 degrees. Okay. Number 3. All right, we have an inscribed angle PQR right here, and then it is intercepting a diameter. I know this is a diameter because it's a chord that goes through the center of the circle. So automatically, using what we know over here with intercepting a diameter, we know that the measure of angle PQR, which we're trying to find, is a right angle, so it's 90 degrees. Okay, let's do some more. Number 4. The measure of arc BC, which is right here. Okay, we're going to work our way over to that. Okay, so what I know from this, I have an inscribed angle with a 47-degree angle. Okay, that's intercepted arc is AC, so you'll double 47, you'll get, what is that, 94 degrees right here. Okay, now notice that arc AC is 94 degrees, we said, and then arc AC with BC make a half of a circle, so they add up to 180. So BC would just be 180 minus 94, which will be 86 degrees. Okay, you're not always going to be given, it's not always going to be straight away what you're trying to find. Okay, sometimes you still use what we know about arcs and all that stuff. Okay, alrighty, here we're trying to find the measure of angle JKL, this angle right here. Okay, to do this, we will find its intercepted arc, which is JML. Okay, we can do that because we have 3 parts of this whole circle, and we know 2 of them, and we know that a circle adds up to 360. So I can do 360 minus those 2. So 360. Hey Siri, what's 360 minus 65 minus 53?
360 minus 65 minus 53 is 242.
Alright, so we found this is 242 degrees. However, that's not our answer. Okay, what we need to do is, we know that the inscribed angle will be half of that measure. So that's going to be, what, 121 degrees, right? Yes, that's right. Awesome. Now the number 6 here. Okay, we have a little, looks like it might be an overlapping arc angle, so let's do this. We're trying to find RST and RUT. So notice they are overlapping. They have the same intercepted arc, which is RT here. Okay, so if we find RT, we half it to find the measure of the intercepted angles, and they're going to be the same. We'll find this arc by, so we can do 360 minus the other parts right here, 75. These 3 parts and RT make a full circle, so 360 minus 75 minus 139 minus 64. Hey Siri, what's 360 minus 75 minus 139 minus 64?
360 minus 75 minus 139 minus 64 is 82.
This is 82 degrees. R2 is 82 degrees. So these 2 angles, you half that 82 degrees, you'll get 41 degrees for both of them. Because we know that if they intercept the same arc, then they're congruent. Okay, number 7. Find each value or measure. So number 7 wants us to just solve for x. Okay, I have this inscribed angle right here is 8x minus 9, and then its intercepted arc is 158 degrees. Okay, so options we have here, I can double this 8x minus 9 and set it equal to 158, or I can take half of 158 and set it equal to 8x minus 9. I'm just going to do that. So 8x minus 9 is equal to half of 158. Hey Siri, what's 1/2 of 158? Hey Siri, what's 158 divided by 2?
158 divided by 2 is 79.
Alright, so we'll solve for x now. Add 9 to both sides. 8x equals 88. So x is equal to 11. Number 8. Okay, this time I'm given an algebraic expression, for the intercepted arc of an angle we have, Ln. Okay, I know half of Ln will be equal to 67, or 2 times double 67 to get whatever the arc is. So I'm going to double the 67. So 4x plus 58 equals 2 times 67. So 60 times 60 is 120. So 134. Subtract 58 from both sides. 134 minus 58. I'm not going to use Siri this time. 76. Divide that 76 by 4. You get that x is equal to 19. Nice. Next problem. Go to the back of the notes. Solve for x. Here, we got a nifty little triangle here. Well, we all notice that our inscribed angle WXY here is intercepting this diameter WY. So I know automatically the angle is going to be 90 degrees. So to solve for x, I can just take the 13x minus 1. And set it equal to 90. 13x will equal 91. And 91 divided by 13 is 7. Okay, number 10. Okay, what we got here. So, we're going to have to do a little messing around here. Okay, so my goal here is probably to use arc XY to do some set up an equation, kind of like what we did with other things over here. However, we're not given arc XY, we're given XW to be 78, and we're given this inscribed angle WXY is 114. Okay, its intercepted arc is WY, so I could find that using the 114 by doubling it and get, what, 228 degrees. And now I use the 78 and 228 to find XY. So 360 minus 78 minus 228. Doing that. That's going to be 54 degrees. So this angle arc right here is 54 degrees. So half of that will be equal to the 7x plus 6, right? Because it's an inscribed angle, it's half of the arc measure. So 54 divided by 2 is 27. So to solve for x, we have 7x plus 6 equals 27. Subtract 6 from both sides. 7x is 21, and then x is 3. Great, awesome. Next. Solve for x here. Again, let's find the intercepted arc first, because we get our expression, it deals with this inscribed angle. So do 360 minus 162 minus 92. We get that this arc is 106 degrees. Half of that is 53, so 7x minus 10 equals 53. 7x is now equal to 63 by adding 10 to both sides, and x is 9. Okay. So this is what I'm giving this arc measure. There's no inscribed arc for there's no inscribed angle for arc RS. However, what if let's just find what we can based on this and see if we can figure it out from there. So I have this inscribed angle 67. I can find QS right here by doubling 67. It's 134. So I know this is going to be equal to 360 minus these two arcs. So 360 minus 120 minus 134. It's going to be 106. And there's my equation. So 5x plus 21 equals 106. 5x will equal 85. And x will equal 17. Okay, that's number 12. Number 13. If the measure of angle FGH is 6x plus 21, and FJH arc, FJH, 17x minus 28, find the measure of arc FJH. Alright, so what I'm going to do, instead of having to half anything, I know that Remember, this inscribed angle is half of the measure of the arc of the it's half of the intercepted arc, or if you double the intercepted angle, you get the measure of the arc. So I can just double the angle, the 6x plus 21, and set it equal to 17x minus 28. So 2 times 6x plus 21 is going to equal 17x minus 28. Alright, so 12x plus 42 equals 17x minus 28. Now subtract 12x from both sides. Get 5x on the right. Add 28 to both sides. 42 plus 28 now is 70. Divide 70 by 5. You get x is 14. So it's not asking for x, it's asking for the measure of fjh. So now we just plug in x. So measure of j, which is equal to 17 times 14 minus 28. 15 times 14 is 238 minus 28. That gives us 210 degrees. Okay, next up, the measure of angle STU is 5x minus 16, and SU is 12x minus 50. Find the measure of angle STU. Okay, now, so again, we'll double the arc measure, the angle measure, the inscribed angle measure, and set it equal to the arc measure. So 10x minus 32, that's just doubling the 5x minus 16, equals 12x minus 50. So 2x is equal to, adding 50, you'll get 18. So x is equal to 9. And then the measure of angle STU from there. Just plug in 9. 5 times 9 minus 16. The measure of angle STU is equal to 29 degrees. Alright, 2 more. Alright, the measure of angle ABD is 6x plus 26. And the measure of angle ACD is 13x minus 9. Notice that both of these inscribed angles, they intercept arc AD, so they have to be congruent. So these two things can be set equal to each other. We want to find arc AD, so our goal is find x, plug into either one, and then double it, and it'll give you your arc AD, the intercepted arc. So 13x minus 9 equals 6x plus 26. 7x equals 9 plus 26. 35. So x is equal to 5. And then what we'll do is plug into either one, whatever one's easier. How about 6 times? Let's do the one with this one because that's 6 times 5 is easier. Measure of angle ABD is 6 times 5 plus 26. So that's 30 plus 26. That's 56 degrees. Now that means the measure of arc AD is double. It's 2 times 56. So it's 112 degrees. And then lastly, number 16, the measure of angle KJL, so that's this angle right here, is 3x plus 2. And the measure of angle KLJ is 7x minus 32. Find the measure of arc KL. Okay, so set up an equation first and foremost. So notice I have the angle JKL is an inscribed angle that is intercepting this diameter JL, so it's 90. So I know that the other two angles in that triangle there have to add up to 90. So my goal here will be to this plus this angle equals 90. So 3x plus 2 plus 7x minus 32 equals 90. 10x minus 30 is 90. 10x equals 120. So x is equal to 12. So to find KL, I used its inscribed angle, which is KJL. So plug in to that. So 3 times 12 plus 2, that's 36 plus 2, is equal to 38 degrees. So KL is just double that 36, or 38, excuse me, which is 76 degrees. And that's the lesson, guys. Your homework is in Edulastic, due Friday by the start of your hour. Some of the stuff might be a little more difficult. If you have any questions, let me know. And your test, again, is on Friday, April 1st. And we review on Thursday for that. Okay? Thanks, guys.